So far we've talked about measures of center of data and measures of variation. And what these got us were, for the entire data set, one number that represented the center or one number that represented how spread out the numbers were or how spread out the data was. One of the main objectives of this lesson, or this part of the lesson, measures of relative standing, are to compare how our if we choose one of our data points from the entire data set, how does that data point compare to the rest of the data set on? Our next measure of relative standing is something called a percentile. Percentiles are a measure of location based on dividing a set of data into 100 groups with about 1% of the values in each group. We use p sub 10 to denote the 10th percentile, which has about 10% of the data below it, and we use p sub 50 to denote the 50th percentile, which has about 50% of all the data below it. Now this is what we called the median before. To calculate the percentile of some value in your data, you take the number of values that are less than that value, divided by the total number of data that you have, and then multiply it by 100 to get a percentage. So let's look at an example. Suppose we wanted to find the percentile for the value 41. As we go through these calculations, it's important to realize that if you look at other books, there will be slightly different ways to calculate percentiles. So stick with these methods for the homework. So first of all, I'm going to count the number of data that are less than 41. And it's important to realize I've ordered my data from lowest to highest. If you haven't ordered your data, then who knows where 41 would fall, and you'd count up all the ones less than that. Wouldn't make any sense. So be sure to order your data before you're calculating percentiles. So I've got 5 numbers that are less than 41 in my data set. I've got 28 total numbers in my data set, so I'm going to take 5 divided by 28 and then multiply by 100, gives me 17.86%. Now I want to round that up to the nearest percentage, so that means 41 is in the 18th percentile. Find the percentile value of 89. So in this case, I'm going to count up all the numbers less than 89, which of course, since there's 28 data points, then 27 of them must be less than 89. So I'll have 27 divided by 28 gives me 96.42, and I'm going to round that up to 97. So that means 89 is in the 97th percentile. Let's go the other way. Now suppose we're given the percentile and we want to find what data value is in that percentile. So in this case, let's find the value of the 80th percentile, or p sub 80. To do that, I'm going to find the location of the data value first. And then once I have the location, I can go to that location and find the actual data value I'm looking for. So n, of course, is the number of data values. K is the percentile that we're looking for. So in this case, since I'm looking for the 80th percentile, my K will be 80. And L will tell me the location of the value that I'm looking for. So a couple notes. If L happens to be a whole integer, we're going to find the mean of the values in the Lth and the L plus 1th position. Otherwise, we're going to round L up to the next integer, and that will be our location. So here's some data. We're going to find p sub 25, or the 25th percentile. So first of all, let's find the location of the 25th percentile. K, of course, is 25 divided by 100 times the number of data points I have, 28, gives me 7. So that means I have to go to the 7th spot, which is 42. And since L happened to be a whole integer, I'm going to average the values in the 7th and the 8th spot. So that means the 25th percentile is 45. Looking at another example, let's find the 20th percentile. So again, we'll start by finding the location. 20 divided by 100 times 28 gives me 5.6. So we're going to round up to 6. That means the 20th percentile is 41. So again, make sure that your data is ordered. Quartiles are very similar to percentiles, except instead of having 100 different percentiles, we're going to have only 3 quartiles. They divide your data set into 4 groups with about 25% of the values in each group. So your first quartile will have 25% to the left and 75% of your data to the right. Your second quartile will have about 50% of the data to the left and 50% to the right. And your third quartile will have about 75% of the data to the left and 25% of the data to the right. So finding Q1 happens to be the same thing as finding P sub 25. And finding Q2 is the same thing as finding P sub 50. And finding Q sub 3 is the same thing as finding P sub 75. So we'll use the same location formula where K, if we wanted to find Q1, K will be 25. So find Q3 in the following table of data. So since we're talking about Q3, which is the same thing as P sub 75, the K in our location formula will be 75. So this comes out to be 21. That means my percentile will be the average of the 21st and 22nd positions. So that is 70 and 72. So my 75th percentile is 71. So the box and whisker plot is a visual representation of Q1, Q2, and Q3 along with the minimum and maximum value. These 5 pieces of information are called the 5-number summary. And drawing it out on a number line, you get a box with some whiskers off of it. And what these represent is this far line to the left represents the minimum value. The far line to the right represents the maximum value. The left end of the box is Q1, or the 25th percentile. The far right of the box is Q3, or the 75th percentile. And this middle line here is Q2, or the 50th percentile. Now, one thing we can get from a box and whisker plot is some kind of summary of how our data is distributed and where the center is. So if you look at this particular box and whisker plot, this distance, 50% of the data that's to the left of 40 here versus 50% of the data to the right, we can see that to the left of 40, our data is all scrunched within 20, so between 20 and 40, whereas to the right of 40, our data is a little more spread out between 40 and 95. So let's look at an example creating a box and whisker plot for this set of data. So assuming this is already ordered, and you can verify that, the minimum is 20. Q1, or P25, is 45, and you can verify that by plugging in 25 into our location. Q2, or P50, is 60. Q3, or P75, is 71, which we calculated a moment ago, and the maximum data value is 89. So, throwing this onto a box and whisker plot above a number line, I get my left end is 20, the left end of my box is 45, the middle of my box is 60, the right of my box is 71, and my right whisker ends at 89.